Okay, so let's see. So let me ask, what is the z-score? What is the z-score associated with the 90th percentile? So what z-score corresponds to the 90th percentile? So don't shout out your answer. Alright, so who thinks they have an answer for what z-score corresponds to the 90th percentile? Okay, somebody else. So what z-score corresponds to the 90th percentile, or something very close to the 90th percentile? What do we have? What do we have? Okay, I'm getting, I say 1.28 is closer, but 1.29 is acceptable. Okay. All right, so how am I getting 1.29? So, okay, let me just have you guys pay attention here. I've got my normal curve centered at 0. And I'm asking, where should I draw my cutoff line so that how much is shaded to the left? Okay, if this represents the 90th percentile, how much is shaded to the left? The area over here is 0.9, right? The area to the left of the 90th percentile is 0.9 or 0.9000 if we want to have 4 decimal places. So what is the z-score that gives me an area of 0.9? That's another way of asking this question. What z-score is an area to the left of 0.9? So I go to my table, and I'm looking for a number that's as close to 0.9000 as I can possibly find. Okay, so I go through, I'm looking through the entire table, and what is the number that's closest to 0.9000? 0.8997, okay? So there's two numbers very close. I've got 0.8997 and 0.9015. And between the two numbers, 0.8997 is closer. Can we find 0.8997 in the table?
No.
Yeah.
I don't know how you got
So look at the table. Okay. See if you can find 0.8997 in the table. Can we find it? Okay. All the numbers are in order. All right. So it's like looking up a word in the dictionary. You're going to have to essentially look through the entire table, but they're all in order, so it's not too bad. You can find 0.8997. Okay. That is the number that's closest to 0.9000 in the table. Is that okay? All right, so what is the z-score that gives me 0.8997? Okay, it's in the row 1.2, and the column that it's in is 0.08. Can we see that?
Why can't it be 0.9015?
Okay, so they're both numbers are very close to 0.9000. Okay, I'm just picking the one that's closer.
Okay.
But I would accept if you chose 0.9015. But the truth is 1.28, 0.8997 is closer to 0.9000 than 0.9015.
So
Yes.
we would write Z score equals 1.28.
Yeah, I would write Z is equal to 1.28. I'm sorry. So Z is equal to 1.28. That is the Z score that corresponds to the 90th percentile. Yes?
So,
Yeah, I would accept either 1.28 or 1.29. I will not accept 1.27 or 1.30. Yes?
Z-score means, this means Z-score, right?
No. The part inside this is the areas. The parts on the edges are the Z's.
Oh, okay.
All right, let's try this again. What Z-score has an area of 0.025 to the left? Or as an area, maybe I'll just write 2.5% to the left. What Z-score is an area of 2.5% to the left, or the 2.5 percentile. All right. Do you have a question or an answer? Okay, so I'm just going to give everybody a minute to figure out the answer, or maybe not even a minute, a moment. Okay, what do we have as our answer? Z is equal to, okay, so Z is equal to negative 1.96. What? Yeah. Okay. So 2.5%, what does that equal in a percentage, or decimal form? Okay, so 2.5% is equal to 0.025. If we go to the table and we look for 0.025, what do we find? The number I can find is, the number that's closest to 0.025, I can actually find it exactly in there, is 0.0250. And that is in the row negative 1.9, and the column 0.06. I have a feeling some of you looked up 0.0025. 0.0025 is wrong. That is 1/4 of 1%. Don't do that. You have to know your decimals and percentages. Don't make silly mistakes. So the Z-score that has an area of 2.5% to the left is negative 1.96. So about negative 2, but negative 1.96. Is that okay? All right. How about this one? What Z corresponds to the top, or top 25%. I'm asking what Z corresponds to the top 25%.
You got 9.7. You got 9.7. Wait, zero.
Okay, do we have an answer?
Yeah.
What's our answer?
0.67.
Z is equal to 0.67, correct. Okay, so in this case, we're looking for the area. So the top 25% means the area to the right is equal to 25%. Is that correct? Well, I mean, is that okay? It is correct. Is that okay with you guys? Huh? So I'm asking for the z that corresponds to the top 25%. I'm drawing a line so that I have 25% above it.
Is it negative?
So how much do I have to the left? Okay, so I have 25% above, I've got 75% below. So what is 75% as a decimal? 0.7500. And I'm looking for the z that gives me the number or the area closest to 0.7500. Okay, and what is the area that I can find that's closest to 0.7500? The number I can find that's closest to that is 0.7486. Okay? So I can find 0.7486 and 0.7517. Which number is closest to 0.7500? 0.7486. Off by 14 ten-thousandths, while the other is off by 17 ten-thousandths. We have to be comfortable with decimals, okay? So, what is the z that corresponds to 0.7486? It's in the row 0.6 and the column 0.07. So my z is equal to 0.67. Yes?
0.68
I would accept 0.68, but the better choice is 0.67. Okay? Alright, is that okay? Using the tables. Alright, so I'll post a question to you. I can keep going and we'll finish a little early, or we can take a break and we go until 10. Keep going, keep going, keep going. Alright. If you need to excuse yourself to use the restroom, that's entirely fine. Okay, so we have to be comfortable with using the z table. Alright?
So when you asked for z, you asked us to look for this number, right?
So the z corresponds to where I'm drawing my cutoff line, and then what the table then provides is the area to the left of that cutoff line. Okay. So, alright, quick question. What if I draw a cutoff line at 3.49? Z is equal to 3.49. Listen up. If I draw a cutoff line at 3.49, how much do I have to the left of 3.49? 0.9998. So practically 1. Okay? So that tells us that at 3.49, I have almost the entire table to the left, but it's not quite that, okay? And if I go out further to say you know, 4 or 5, z is equal to 4 or 5, I get something that's very, very, very close to 1, but not exactly 1. And in the opposite direction, if I draw a cutoff line at negative 3.49, the area to the left of that is practically 0. It's like 0.0002. Okay, so it's very, very small. Okay, so this is our discussion of the normal model. I'm going to skip the very first section in chapter 6 in this lecture. There are a couple homework problems from it, but the questions from 6.1 will not be on your midterm exam. But there will definitely be questions from the normal model. So when we talk, I apologize, okay? When we talk in chapter 3, from chapter 3, we learned about z-scores. Is that right? What was the definition of a z-score? Okay, so a z-score is the number of standard deviations
Away from the mean.
away from the mean. Good. We use z-scores as a way to compare items from different groups. I could ask you, if the average male tiger weighs this much, and the average female tiger weighs this much, and the standard deviations of each group is this and this, I could say which is more unique, a male tiger that weighs this much, or a female tiger that weighs this much. What we would do is we would turn them into z-scores, and based on the z-scores, we can make a comparison. I hope that sounds familiar to you guys. I'm sorry? Yeah, it was on the quiz, and it's something that you are expected to know. So the z-score is the number of standard deviations that we are away from the mean. To find the z-score, we say we take our point, not y, but x, minus the mean divided by the standard deviation sigma. Is that okay? Or x minus the mean divided by the standard deviation. Okay? Where mu is equal to the mean and sigma is equal to the standard deviation. These are just symbols for mean and standard deviation. Yes?
Is it X bar?
Yeah. So in chapter 3 we learned x bar and s, or the mean and standard deviation. In chapter 6 the symbols are changing because we're talking about models. And so the symbol for mean is mu. It looks like a U with a line in the front. And the symbol for standard deviation is sigma. It looks like, I don't know, like an O with an extra tail. Sigma and mu. So this is called mu, and this is called sigma. The mean and the standard deviation. And this makes sense because x minus the mean tells us how far we are away from the mean, right? But we don't want the distance just in units. We want the distance expressed in standard deviations. So we take that distance from the mean and we divide it by the standard deviation. And that tells us the number of standard deviations we are from the mean. Okay. So the z-score is the number of standard deviations we are from the mean. X minus the mean, or x minus mu, tells us the distance we are from the mean. But we don't want the distance, we want the distance expressed in standard deviations. So we take that distance and we divide by the size of the standard deviation to see how many standard deviations we are from the mean. Okay, so that's a z-score. Now, it's not a coincidence that we are using z-scores, and our normal model table is called a z-table, because if things come from the normal distribution or the normal model, once we turn them into z-scores, we can find percentages associated with that. Okay, so for example, let's say we're talking about IQ scores. So IQ scores come from a normal distribution. The mean IQ score is equal to 100. The standard deviation of IQ scores is either 15 or 16, depending which test you take. But we'll just say the standard deviation is equal to 16. So if I were to draw a normal model for the IQ scores, what score goes in the middle?
Oh,
100, right? This is the mean. And for the normal model, it's symmetric, so the balancing point is right in the middle. The mean score is 100, it goes right in the middle. So if I asked you, what percentage of people have IQ scores lower than 100, you would tell me, what percentage of people have IQs lower than 100? So 50% of people have IQ scores lower than 100. Is that something, does that make sense? Okay. I could ask another question. What percentage of people have IQ scores lower than 112? Say, what percentage of people have IQ scores lower than 112? Well, how should we answer this? This can be answered by using z-scores. So what is the z-score of someone who has an IQ of 112? Don't shout it out. Figure this out. We've covered this in chapter 3, so it should be something you can do. The z-score, someone with IQ equal to 112. So the z-score of someone with an IQ of 112, what is that person's z-score? Okay, so just see. Are people even attempting this, or are you just waiting for me to give you the answer? Huh? Okay, so who can tell me the answer other than Eudor? 0.75. Great. Okay, so we get z equal to 0.75, right? So we just say z is equal to 112 minus the mean of 116 divided by the standard deviation of 16. The mean of 100. Sorry, mean of 100 divided by the standard deviation of 16. I get 12 over 16. Z is equal to 0.75. Yes.
So we get the
So I'm just finding the z-scores here. All right. So I'm drawing a cutoff line at 112, and I'm asking what percentage of people have IQs lower than 112. Okay. So I want to know if I shaded everything to the left of 112, how much would I have shaded? Well, our normal table doesn't tell us that answer directly, but if we turn them into z-scores, it will. So 112 corresponds to z equal to 0.75. And how much, according to our table, what is the area smaller than 0.75?
0.67.
So I would look up z equals 0.75, and I'm getting 0.7734. Am I doing something?
0.7486.
Yeah, why is 774? Oh,
Yeah, z is equal to 0.7. 12 over 16 is 75, no?
Yeah,
Did I
it is
mess up?
0.75, but
But
it's,
then when you look in the actual
but
graph of
I think I'm getting out, because you're trying to get 0.75, right?
No. I'm asking what percentage of people have IQ scores lower than 112?
So it's 67%, right?
No. The z-score is equal to 70.75. So my z is equal to 0.75. So I go to my table, and I go to the row 0.7, and the column 0.05,
You get 0.7734.
and I get 0.7734.
So 77%.
So 77%. Okay. Is that okay? 0.7734, or 77% of people have IQs. 77.34% of people have IQs lower than 112. Is that problem okay? So let me give you another example that you are then to solve. Okay, so let's say, I don't know, male tigers have a mean weight, I don't remember, let's say 460 pounds. And the standard deviation is, let's say, 43 pounds. What percentage of male tigers weigh more than 500 pounds? Let's see if you can answer that.